So we're going to look at a couple other functions that are handy, a little more advanced, but not as, and so they're not as critical, but they're still useful. We're going to look at the trigger bits here. Then we're going to look at coupling. So we still have our same circuit, little 555 timer turning on and off very, very fast. And then, so we have the output and then the input for the trigger. And what we're going to do is we're going to look at the trigger on the oscilloscope. So we don't need channel 2 right now, so let's turn that off. Turn that off. And there's channel 1. Now, right now, everything's nice and steady and all that, but if I move the trigger, and you can see a little line moving up and down here, if I move that off of there, we're now getting this running image, so it's very hard to see and figure it out. And what the trigger level does is it allows us to lock this screen so it freezes it. So if we move the line up till it gets into there, it's now frozen. What's happening is when this signal goes up, it tells the oscilloscope to start tracing. So that's when it starts tracing, and it comes around, does it again, keeps doing it. This little arrow here means that that's where the trigger is. So I can move this back and forth to the horizontal position. So if I have some stuff that's spreading out that way, I can move it like this. And I can see everything going that way. So it starts here and goes this way. I can hit the set to 0 and it puts everything back to the middle, like so. And so what the trigger, like I said, what the trigger does is basically it freezes the screen for us by telling the oscilloscope that, okay, this is the amount of voltage that if that voltage comes across, you're going to stop and take a look like this. Now, we can do a couple of things with this one here. So if I hit here, whoops, wrong one. I want a trigger menu. There we go. So if we hit trigger menu, there's various things here. We can change the source, and we can change the type. So right now it's on edge triggering. So when it sees that edge, it goes up. But it can also look at pulses, in which case, in this case, it's going to be look a little different. But mostly you're going to use edge triggering. And then slope. Now if you notice the little line here where the trigger starts, it's on the rising slope. What we can do is we can change that to the falling slope. And now everything's shifted over, because now when that falls, it triggers and then starts recording. We can also put it on rise fall, which on this here will cause it to bounce back and forth between the two. So let's put that back on rise for now. And leave it on edge triggering. Okay. So that's what the trigger does. Now, that's what it's doing, especially with this nice straight edge. Let's see what happens when we have something a little less straight. So here is our channel 2. It's more of an AC, analog signal. It's not just an on and off, but it does have rising and falling. And we can change the trigger over to channel 2 by going here and going sources channel 2. And then we can get rid of that. And now channel 2 is the trigger. Now you notice it's moved over a little bit because where our trigger is, and where that lines up right there. And I can make that go up, move up, and then we'll start flying all over the place. Or I can bring it back down till it gets down to the bottom there, then it'll start flying all over the place. And if I change it, I can change it again to falling edge, in which case now it moves over and now we're looking at the falling edge. And as I move the level up, we get the same effects, except now we're on that falling edge. And in this case now too, if I make it rise and fall, it'll again will fly back and forth. However, there's a point when it's not rising and falling that much, which is right at the top. So I get it just right. It'll slow it down, or at least not bounce as much, because it's not going very far. So we'll go back to there. Now, another thing about source, there's a couple other places we can get the source from. We can get external, In other words, an external trigger here for some external device that, you know, sets a signal and then everything happens. You can use the AC line. In other words, the 60 hertz from the AC line. External won't work because there's nothing hooked up to it. AC line also won't work on this one because none of this is at 60 hertz. But if we put it on alter, it'll jump between 1 and 2. And that's useful if your two signals aren't lined up nicely like this one. It behaves nicely because it's lined up nicely because they're both showing the same thing. But if we have two signals that one's nice and stable and the other one's changing a lot, alternating gives you a chance to make them both kind of stop. Well, let's put it back to channel 1 here. Actually, we'll put it on channel 2 because what we're going to do next. All right. So that's what triggering does. Like I said, it's useful to, like I said, freeze your display. Now, the other thing we're going to look at is coupling. So right now, and this is what's called DC coupled. So it assumes that it's a direct current signal. This here is technically an AC signal because it's going up and down. But since it's all above 0, it sees it as a direct current. Now, if I wanted to put channel 2 here, let's say I wanted channel 2 to be much bigger. Okay, so, whoops, wrong button. There we go. Let's say I wanted it to be 1 volt instead of 5 volts because I needed the resolution, because maybe it doesn't go up and down very much. I can do this, but now I can't see part of it because it's off the screen. Now, yes, I can move it down, like so, and now we get that. But now we've got this little gap between the ground for 1 and the ground for 2, and if this is basically a DC offset, a direct current offset, if that's really big, it's going to go off the screen again anyway. So how do we fix that? Well, we can bring everything back to here. So now we have everything lined up again. But what I can do is I can bring up my channel 2 menu here, and it says here coupling, and right now it says DC. Well, if I can go AC, and then I'm going to go get out of that menu. Now we have to readjust our trigger because the trigger was way up there. Now I can bring it down. That's at 0. There we go. Sometimes if you can't find it, just hit there's often a 0 button. Just hit that, it brings it all. And now we have our up and down lined up. Okay, so our ground is right there. And now it's going up and down as an AC. What AC coupling means, what it does is it takes the DC component out of the signal. So now you can just see the AC bit, and now you can line them up like that. So we can now, you know, scale this down or up as we need, and that'll give us, you know, good view. The other option that we saw on this coupling is ground, and all putting it on ground does is it basically grounds the channel, and that shows where the ground level is right there. Okay, so at 0 volts, and then we can put it back on DC coupling, and it'll go way up there again. We can just bring the scale back down again. Bring it back there, and then we can move that into there, and then we're back to the way we were before. We could also put our trigger back on the channel 1, and there we are. So those are those two functions, and that's the vast majority of all the regular functions you'll find in pretty much every oscilloscope. There are other functions on this. There's ability to do math and measure and all sorts of things. Those will vary depending on oscilloscope manufacturer, model, and all that stuff. But the ones we've shown, which are the horizontal and vertical controls and the trigger controls and doing the coupling, that's on every oscilloscope. And so those are good to know. Again, if you have any questions, please ask.